You're welcome to the section of the correction of the chemistry assessment of the third week at the Science Hub Academy. So today we will look at the review and the correction of the assessment given for the third week. So question 1. As we can see on the screen, the first question says, a hydrocarbon has an empirical formula CH and a vapor density of 39. Determine its molecular formula. So empirical formula multiplied by N definitely gives us the molar mass. So since the empirical formula given is CH into the bracket of N equals to, here we are given the vapor density, and we know that 2 multiplied by vapor density will definitely give us the molar mass. So as a result, you say the empirical formula multiplied by N equals to the vapor density times 2, so that would be 39 multiplied by 2. So the value of C there is 12 plus 1 into the bracket of N gives us 39 multiplied by 2, that gives us 78, right? So this gives us 13N is equal to 78. So then N will be equals to 78 divided by 13. So the value of N is therefore equals to 6. And so from there we can put in the value back into the empirical formula. So C H into the bracket of 6. So that gives us C6H6. So the answer to that is C6H6. Now the second question. A silicon containing ore has 92% 28 silicon. So our M1 there is equal to 28. And our alpha 1 is equal 92%. Right? So on the 5% 29 silicon. So our M2 is equal to 29, which is the atomic mass. And then our alpha 2, relative abundance of isotope 2, is equal 5%. Then our M3 is therefore equals to 30, and our alpha 3 is equal to 3%. So with this we can calculate the relative atomic mass. So that will give us M1 alpha 1 plus M2 alpha 2 plus M3 alpha 3. Alpha 1, that's 0.292, then plus M2, that's 29 multiplied by 0.05, then plus 30 multiplied by 0.03. So let's add them up all together. So the relative atomic mass will be equals to what? So the final answer there will give us 28.11. So the answer to that is 28.11. So that's that. So number 3, how many protons, neutrons, and electrons respectively are present in this? We have CO, that's cobalt. This is 27, and this is 60. So from this, to get the number of protons, we know that's going to be equal to 27, because the atomic number is the same as the number of protons in an atom. To get the neutron is mass number minus atomic number, so that will be 60 minus 27. So the number of neutrons will be 33. And finally, here we have electrons. So to get the number of electrons, that's definitely going to be the same as the atomic number, which is 27 number of protons. So the answer to that is going to be equal to protons number. According to this, proton is 27, right? Neutron is 33, and electron is 27. So the answer is this: 27, 33, 27. Now here the fourth question says that the difference in the electronegativity of element P and Q is 3. So meaning that electronegativity difference is 3, right? So what type of bond is formed? So here we need to understand that when the electronegativity difference is greater than 1.7, this is often common in ionic compounds, right? So when the electronegativity difference right, is less than 1.7, let's say it's between 0.4 to around 1.7. This is mostly found in polar covalent compounds. And when the electronegativity difference is approximately 0, very close to 0 or even 0, this is found in non-polar covalent compounds. Non-polar covalent compounds. So these are the ways by which you can identify that. So the answer to this is most likely ionic compounds. Now the next number 5, says we need to calculate the percentage of sulfur in sulfur 4 oxide. So the chemical formula for sulfur 4 oxide is SO2. So to get the percentage of sulfur, so that will be mass of sulfur over mass of sulfur 4 oxide times 100. So to do that quickly, we need to calculate the atomic mass of sulfur. We are given sulfur to be equal to 32. So that will be 32 over the summation of this, that is 32 plus the atomic mass of SO2, 16 times 2. So that is 32 plus 32, so that will give us 64. So this will be 62 divided by 64 times 100. So, and that will give us 50%. So the answer to that is 50%. Now the next number is to determine the shape of carbon 4 oxide, CO2. You know CO2 looks this way when you draw the structure. So it has a structure like this, and this structure is definitely linear, right, with a bond angle of 180 degrees. So that is going to be this. Now number 7, if the element X and Y have atomic number of 11 and 17 respectively. So X is 11, so the electronic configuration is 281, and Y is 17 with electronic configuration of 287. Definitely this is a metal because it has 1 valence electron, and this is a non-metal, it has 7 valence electron. So the kind of bond you find between a metal and a non-metal is actually ionic bonding. So that is the answer. Now number 9 says calculate the percentage by mass of nitrogen in nitrogen triazonitrate 5. So calcium triazonitrate 5 is actually Ca into bracket NO3 2, right? So we need to calculate the percentage of nitrogen in that. So we have 2 atoms of nitrogen. So we are having 2 nitrogen divided by the whole of these, right, multiplied by 100. So this is definitely going to give us 2 multiplied by 14 over the whole of this. If you're to calculate, that will give us 40 plus that is 28, that's 14 times 2 plus 16 times 6, right? So the whole of this will give us that's 68 plus 96 to give us 164, right? So then this is going to be divided by 164 times 100. So if you have to calculate that, so that will be 28 divided by 164 times 100. So let's calculate that, let's compute. So what would that give us? That gives us 17.07, which is approximately 17.1. So here is the answer to that question, number 9. Now question 10, given that the relative atomic mass of chlorine prepared, so we are given the relative atomic mass here to be 35.5. So, and you are told that it is in 2 isotopic mixture. Our M1 is 35 and our M2 is 37. So what is the percentage by ratio of the composition of the mass of 35? So if you pick this M1 to alpha 2 to be equal to the relative atomic mass, which is 35.5, so here mathematically we'll be having 35 multiplied by, let's assume this is X%, and so that is going to be X, right, over, so this is over 100, right? So that's X% then plus N, so that will be 37. Our alpha 2 would therefore become, since the percentage of alpha 1 is X, so the percentage of alpha 2 will definitely be let's assume that is going to be 100 minus x over 100. So in all, this is going to give us 35x over 100, then plus this will give us something like 3700 minus 37x over 100, everything equals to 35.5. So at the end, you have the LCM here is 100, and then we do the computation. This is 35x plus 3700 minus 37x equals to 35.5. So here, that's this minus this will give me, that's 35x minus 37x will give me minus 2x, right, plus 3700 equals to 35.5, then over 100. So we can cross multiply, and so that will be minus 2x plus 3700 equals to 3550, yeah, 12. So, and then with this we can easily estimate that. So we can take this way, so that will be 3700 minus 3550 equals to 2x. So this is going to give us 150 equals to 2x, and x is therefore going to be equals to 75. So it implies that x here is 75, which is what this. Number 11. The three-dimensional shape of methane is, so we know methane, that's a CH4, so it's like this, right? So having something like this as a structure. So now this is standing for methane, and methane is actually considered to have tetrahedral shape, right? So that's said to be tetrahedral. So the answer to that is this, tetrahedral. So the number 12, the formula of a compound in a reaction between M, that's a trivalent M metal, and a tetravalent non-metal. So if X is a non-metal tetravalent, 4 negative, so this will be 4 M4 and X3. So which one is most appropriate here? And this is here. Question 13. An electron can be added to a halogen atom to form a halide ion with. So we know generally halogens used to have 7 valence electrons. For example, chlorine 17 with 2, 8, 7. So when it gains 1 electron negative, so that means it's going to have 2, 8, 8, which implies that the valence electron becomes 8. So that is this. Number 14, the shape of s orbital. We know the shape of s orbital looks like this, with the x-axis here. So, and this is known as spherical. So the shape of s orbital is spherical. So here is the option here, spherical. Now question 15, calculate chlorine consisting of 2 isotopes of mass number 35 and 37 in the ratio this. So here we know the M1 is 35, M2 is 37, then alpha 1, that's ratio 3 over 1 plus 3, then alpha 2 is 1 over 1 plus 3. So my alpha 1 is therefore 3 over 4, and my alpha 2 is 1 over 4. So the relative atomic mass therefore becomes M1 alpha 1, which is 35, multiplied by the alpha 1, 3 over 4, plus M2 alpha 2, that is 37, multiplied by 1 over 4. So let's add them up all together. So we have in 3 multiplied by 35 divided by 4, then plus 37 multiplied by 1 divided by 4. So in all, we're going to have 3 multiplied by 5, that's 105 divided by 4, plus 37 divided by 4. So let's add them up together. So that's going to give us 142 divided by 4. So what is 142 divided by 4? That is That is 35.5. So the two isotopic mixtures are in okay, for this 37, so that's going to be 25 according to our question. So I really do not want to take it back again, so I hope this is understood in a way. So there's any other way there's still other ways by which you can actually solve this question. Okay, number 16, the Bohr model of the atom proposed the existence of what? I think that is an electron shell, because it was able to give us a principle of quantized electron, so whereby electrons are actually fixed in a particular energy level, and this energy level are the shells. So we can have the K shell, the L shell, the M shell, and so on and so forth. So electrons are always fixed according to Bohr's model within this energy. So that's electron shell. So that was the proposition that was done by Bohr's model. Yeah, number 17, the mass spectrum can actually be used to estimate the mass of, that's definitely an atom. So we use the mass spectrometer to detect the mass of an atom. Number 18, what is the number of an element whose cation Y plus, so this is Y plus, has an electronic configuration of 1s2, 2s2, and 2p6. So in all, when you calculate the number of electrons, that will be 10 electrons. So Y2 plus is having 10 electrons. So that means in its atomic form, before losing electron, it had 11. Before losing one electron, it had 11 electrons. So that makes it to have an atomic number of 11. So this is the answer here. Number 19, what is the shape of water molecule? Now we know water molecule is like this in shape. We've done that. So if this is the shape of water molecule, so water molecule has an angular shape, or a bend shape, or a V shape. So the answer to that is actually bend shape. Right. And here finally, how many lone pairs of electrons are there in ammonia? That's NH3. So NH3 looks like this. Right, so we have this with this as the lone pair. So we've also done this in our previous classes, so you can check back in some of the videos we've done previously on bonding. So here is the lone pair of electrons. It has just one lone pair of electrons.